and I am the teaching assistant for this course. The course pertains to the basic construction materials, which we'll be using in our constructions actually. And here the session is particularly pertains to doubts clearing session. And first, I'll introduce the contents, what we are going to see in this particular week. Later on, we can move on to some sample problems, and then we can move on to some doubts clearing session also. And if you would like to introduce yourself, you can please carry on with it. I'm audible here again. Hello. Okay, let's start the session. Can you able to see my screen? Okay, this is an NPTEL course. The course name the Basic Construction Materials, and my name is Monica, and I am one of the teaching assistants for this particular course. And if we go to this outline of the course, you can see there are two aspects in this course. The first aspect deals with the basic information on the structure and properties of the construction material. Like, for example, if you take a construction material such as steel or concrete, then before going for the application of it in some construction or something, first we should be able to, we should have some understanding about the structure and the properties, the material properties of the particular construction material which we are going to have. So the structural properties of the construction materials basically pertains to what are all the types of bonds which are included in the structural properties, and what is the mechanism of damage and failure in the material. So suppose if you take some concrete or steel or some other material, there will be some failure or damage mechanism to the particular. There will be some failure or damage mechanism which pertains to that particular material. So first we should understand what is the structural property which we have for the particular material, and what are all the types of bonds which are included in that material, and what is the mechanism of failure or damage in the material. So suppose in case of concrete, we can test it in two ways, either in tension or in compression. We can test it and we can obtain the damage profile of the particular material. That is the first aspect which we will be going to deal with in the course. And the second aspect deals with, we will get an introduction to different materials which will be using in the construction industry, like such as wood, timber, steel, concrete, polymers, plastic, etc. So this is the second part of the course outline. So finally, we can say that the objective of the course is to we have to be like after the end of the course, you can see that you will be able to link the material choice with the application in construction. For suppose if you're gonna build some, if you want to go for some construction or something, first you have to select the material. Either you want to construct it with concrete, steel, or some other material. So for that, for the choice of the material, and the choice of the material should be like you should be able to apply it in the construction scenario. Uh, that is the final objective of the course. So, for suppose this is a 12-week course, right? So, from first week till third week, so from first week till third week, we will be dealing with structure and properties of the material. Um, the um, the rest of the topics which are included in the structure and properties of the materials are like fundamentals of the so structure of the material includes the fundamental properties of the materials. For suppose it starts from the atomic bonding. From atomic bonding to the failure theory. Atomic bonding, like if you see some material in microscopic level, you can see the type of bonds. In microscopic level, you will be able to see the type of bonding between the molecules which are in the element. And it starts from the atomic bonding till the failure theories, like under some kind of load, either it will be axial load or transverse load or something. What will be the failure mechanism of the material and structure and property relationships. Then we can see the general engineering properties of the materials, such as stress strain characteristics, etc. So from week 1 to week 3, we'll be covering these aspects. So now week 1 pertains to the topics such as what are all the common construction materials. Anyone wants to uh, everyone was fine with the audio and video. So, common construction materials and evolution of materials and common types of construction. Like, see, in the case of common construction materials, we can see what are all the materials which are available for construction of any type of structure, such as agatha, timber, concrete, steel, etc. And evacuation of materials. Like now, we are in a stage of using steel, reinforced concrete structures, and some admixtures or something we can add for this reinforced concrete structure for additional strength or some other particular property. Like, but uh, from the starting level, if we can see, um, in the earlier days, we don't even know what is this reinforced cement concrete or something. So earlier days, we used to do the constructions out of rock carving, and then directly we'll be carving the rock. There will be no uh, will not do any will not be using any bonding material or something. We'll just carve the structure out of the rocks, and later that will come under this monolithic construction. And after that, we went for wood type construction, then masonry, then then steel. Like we have many like we started from um, ancient constructions like carvings, and now we are at the stage of using steel, glass, reinforced cement, concrete, etc. So the evolution of materials also we can see here, and the common types of construction. See, based on the see this common type of construction methodology also comes hand types of construction methodology also comes into line with the evolution of materials. Based on the material, the construction methodology also changed from earlier days to uh, nowadays, like from earlier days to the present type of construction methods, and the behavior of construction materials. The construction materials means apply a type of load. So suppose we have different types of loading, like add load, transfer load, and like that. So when the type of load varies, also the behavior of the construction material also varies. So we can also see the behavior of the so if I start with the introduction of the building materials, why building materials are an important concern to us? Because when you see a particular structure, the rate and quality of a construction work, it will be based on the building materials which have been used for the particular construction. So that's why the building material study of the building materials has been an important aspect of civil of the construction industry. And uh, the choice of material also. For suppose now we have many types of materials in hand if we want to go for the construction. But the choice of the materials is also very important because the material choice will be changing based on many aspects, such as see for suppose this climatic conditions. Uh, Based on the climatic conditions also, we have to check for the choice of the material. But suppose if you are in very high temperature zone, then you can't go for a glass type of construction. So the choice of construction material very well depends on the climatic conditions and availability. The second thing is availability. For suppose if you are in some location and the availability of one type of material is high and the another type of material is very low, then you should also see that aspect also, because if the availability is very less, if the availability of a particular material is very less at the construction site, then you have to include the transport charges also in the construction charges. Like so, the transport charges also will be high, and then the cost effectiveness will go down. For suppose if you take a material which has uh, very high cost effectiveness, but it is not available at the particular location, then because of the transport charges, again this cost effectiveness will go down. So you have to consider that aspect also. And the performance aspect. Performance comes like the durability and service life of the structure. For suppose if you consider the serviceability of a structure, serviceability means the structure will not be failing, but you will the structure will not be serviceable. For example, if you have constructed a house, what is the purpose of construction of a house? It needs to give us shelter. It needs to give us shelter and comfort. If suppose if the structure is not serviceable anymore, means the function of the particular type of structure is is not being met. So then we can say the structure is not serviceable. For suppose if some cracks or some slight deformation occurs, then you can't feel safe in the house which you have constructed. In. So it should be serviceable and durable also. So that in performance aspects, that comes like the durability and service life. And aesthetics. Aesthetic is also a very important criteria. Like if you see the building from outside, the look has to be nice. The look has to be pleasing. So aesthetics also play an important role in the choice of the materials. And why we have to have the knowledge of these material properties? Because when you go for the choice of particular materials for some specific service conditions, then when you have the knowledge of the material properties, then you will be able to choose the appropriate material which we need for the type of the construction. And here, the common construction materials which we have in hand now are steel, concrete, wood, polymers and plastics, and some other materials like glass, uh, other materials like glass and composite. So these are the common construction materials which we can which we have in hand now. Uh, by this, I'm just giving an outline of the. Yeah, through this, I'm just giving an outline of the course, and now I'll go through some sample problems. Uh, if you have any doubts prior to that, you can ask, or else after the after the explanation of the sample problem, also you can raise your questions. If you have any questions, you can ask me. Any queries? Okay, then I'll proceed with the questionnaire session. The first question is, which of the following stresses are used for identifying the quality of structural steel? Uh, can anyone answer the question? Actually, this is the doubts clearance session, so you can feel free to ask any kind of questions. And if we can, if the conversation is go in wider ways, it would be better for both of us. Uh, see, in case of structural steel, what kind of stress is used for identifying the quality of the structural steel? Okay. Um, First, let me explain the what is the strain and what is stress and what is the stress strain curve. See, when you This is the typical specimen curve in patient. Okay, so in exercises will be having the in biology will be having the stress. Um, and here, which is the dependent one and which is the independent one. Okay. See, actually, this is the dependent quantity, and this is the independent quantity. The strain depends on the stress. What is stress actually? When you apply some kind of load on any material, it will offer some resistance to that load. Like when the load is applied externally on an object, then the object will have some resistance towards it. So the internal resistance offered by the material for the upload applied externally, that is called stress. And the stress can be calculated using the formula like what is the external load applied, the ratio of external load applied to the area of cross section of the material. So by using that, we can uh, get the stress. And what is strain? Anyone? Okay. So because of the application of external load, there will be an internal resistance that is called stress. Okay. Uh, then, if you come to the strain, because of this applied load, there will be change in the length of dimensions of the specimen. Okay. So, for suppose if you take a bar and if you apply some axial load like this in both the directions, then what will happen to this particular bar? Then it will get elongated, right? So the dimensions are getting changed here. Now this is the original length of the bar. After the application of some external load, there will be some elongation in the bar. So the change in length to the original length, the ratio of change in length of the bar to the original length gives the strain, gives the strain which has been caused due to the application of external load. So if you if you see from this graph, you can see this is the first zone. The first zone is known as linear zone. Linear zone is nothing but uh, the strain is proportional to the stress which has applied on the on the particular material. Okay, when you like the amount of stress and strain are proportional here. That's why the curve is linear up to this point. For suppose O is the origin point and A is the proportional limit. So from zero O to A, the the zone is known as linear zone. That means the stress is directly proportional to the strain. So stress and strain are directly proportional in this particular zone. And after some time, if we further load the material, then what will happen? Then the material will no longer be in the elastic region. For suppose this linear region, we can also say this as elastic region because when uh, when you load the material, it is reaching the proportional limit. Uh, but when you unload the material, it will come back to the original position. It will come back to the original position. So till this point, it has some elasticity property in it. But after that, it will no longer be elastic. It will no longer be elastic, and there will be a sudden uh, increase of stress from this point. And after that, even though there is no increase of stress, there will be an increase. There will be the strain. We can see the strain even though the strength is constant. This region is known as perfectly plastic region or elastic region. That means the molecules in the particular material will lose the bonding and it will get elongated. So this region is called perfectly plastic region. And after that, uh, if the material is ductile, instead of after the plastic region, instead of going to the failure, it will elongate more. It will elongate more with lesser application of load. Even though the load applied is less, with the strain will be increasing. So that's why this is known as strain hardening region. This region is known as strain hardening region. But after that, after reaching some uh, ultimate point, it will start. Uh, it will undergo necking. Necking is nothing but changing like the reduction in cross section. For suppose in this bar, if I am testing it in tension, so in both the ways I'll be applying load, upward and downward force. So because of this, the material will get elongated. The material will get elongated, and because of the elongation in the center of the material, you can see some reduction in the area of the material. Okay, so that is known as necking region. And after this necking region, if you further increase the if you further increase the loading, then you can see the material will get failed. The material will get failed. That is known as fracture point. So this is the ultimate point. And if you can structural steel is a ductile material, right? The structural steel is a ductile material, whereas the concrete is not a ductile material. So concrete is a brittle material, so it will not have this strain hardening region. It after this plastic, after some heat region, it will reach the ultimate value. So it will not have this strain hardening or necking region. What is the importance of a ductile material? Why ductile material has more prominence than a brittle material? Because a ductile material will give a warning before the failure, because it is getting elongated even before the failure. It is showing some elongation or some deformation properties to it before the failure. It is not failing suddenly. So it is giving us some warning. So that's why we'll go for ductile material. That is the reason why from concrete we have come to this reinforced cement concrete. That is the reason behind that, because concrete is a brittle material. It is not strong in tension. It is strong in compression, but it is not strong in tension. That means when a tensile load is applied, it will not show any warning. It will suddenly fail without this strain hardening region and all. It will suddenly fail. That's why what we have done is we have incorporated this structural steel, which is strong in tension and which is a ductile material. So if you combine this both cement and steel, then you can take care of both compression and tension. When the compression loading, when the concrete has to take the compression loading, it will be able to take care of it. But when it has to take this tensile load, it will not be able to take care of the tensile load. That's why if you incorporate steel in the tension region of concrete, then it will take care of the tensile stresses which are going to come onto the particular material. So this is the fracture point. So if you have to look into the quality of the structural steel, we can see the ultimate stress, which it is ultimate stress, which the steel will be able to take take the particular stress. Stress will be calculated Newton per unit scale, because it is uh, it is the ratio between the applied load and the cross-sectional area. So when you have to see for the quality of a structural steel, then if you see the ultimate stress at which it is going to ultimate stress at ultimate stress, which the strain is capable to take, then you can understand whether the structural strain is of a good quality or not. So, are you able to follow up with the questions? Or if you have any doubts, you can raise at any time. Audio is not clear, and you can tell the like you can unmute your audio and you can tell the answers if you are willing to answer the question. Then it will be it will be like a spinning forum there. Is everything okay? Okay. And the next question is the ratio of Young's modulus of high tensile steel to that of mild steel. What is the ratio of Young's modulus? See, first I'll let you know what is the Young's modulus here and what is the importance of that. Young's modulus is nothing but the slope of the this curve which up to the proportional limit. The slope of the stress strain curve up to the proportional limit, or the slope of the stress strain curve in the elastic region. It is known as elastic modulus. See here you can see from O to A. This is the elastic region, and A is the proportional limit. Okay. So in this region, if you take the slope of this line, then you can arrive at the elastic modulus of the particular material. So it is nothing but the ratio between stress and strain. The ratio between stress and strain. So that is the elastic modulus. Here the question is the ratio of Young's modulus of high tensile steel to that of mild steel. What is the difference between high tensile steel and mild steel? Actually, the difference pertains to the amount of carbon content in the steel. If it is high tensile steel, then the carbon content will be more. And if the carbon content is more, then what will happen? See, if the carbon content is more, then the ultimate strength of the steel will be higher when compared to the mild steel. The ultimate strength of the this hybrid steel will be higher, but the ductility will be less. The ductility will be less. See, um, ductility is less. So suppose the ultimate point which you are seeing here will be higher in the high grade steel, but it will not have this much of strain hardening property or this plastic region. Okay, so that is the main difference. But the question here pertains to the Young's modulus or the elastic modulus. When when you see the Young's modulus or elastic modulus, this is the ratio which we have to see. This is the slope which we are going to take in this elastic region. So for even for mild steel or for higher grade steel, this ratio is not going to change. Only this strain hardening ratio and the ultimate ultimate strength will be varying. So this will be a constant in both the grades of the steel. So then we can say the ratio is when when the when the both are same, then you can say the ratio is 1, right? So here you can say that the Young's modulus of high tensile steel to the top mild steel is 1. Fine. Any doubts? So the next question, limit of proportionality depends on. What is the limit of proportionality? So if you can see this stress strain curve, you can see this is the proportional limit. That means the limit up to which the material will be in elastic region. This is the proportional limit. So this is the proportional limit. And which aspect this will depend? This will see these are the options. It depend on it's not actually all of the above because it doesn't pertain to this area of cross section or the type of loading. Why? Why is it so? See, it doesn't depend on this area of cross section or the type of loading. It will only depend on the type of material. It will only depend on the type of material. Based on the material only the stress and characteristics will be changing based on the material type. It doesn't depend on the type of loading or the area of the cross section. Only it depends on the type of the material which we have considered. Based on that, the limit of proportionality will be changing. Okay. For suppose if you take some brittle material or some material which doesn't have that much elasticity nature, then this proportional limit will be lesser, and this allows linear ratio will be lesser in such type of material. So next comes to the limiting. What is the limiting value of Poisson's ratio? First of all, let me explain you what is meant by Poisson's ratio. Any idea what is meant by the Poisson's ratio?
Yes, ma'am.
See,
Ma'am,
it is basically the
ma'am, बोलोगे?
ratio between lateral strain to the longitudinal strain. Lateral strain to the longitudinal strain. I have already explained what is meant by strain. Okay. The strain is the ratio between change in the dimensions of the material to the original dimension. Change in uh, dimension to the original dimension. For suppose if I go for some again the same axial load, this is the member. This is like some vertical member, and I am applying axial load on both the ends. Axial load on axial tensile load because I am. This is the upward load and this is the downward load. So it will be the loading is axial tensile load. So when you go for it is represented by nu, and it is the ratio between lateral strain to the longitudinal strain. What is meant? So if I suppose if I am applying load onto this material, it will get elongated, right? It will get elongated in the longitudinal direction. Okay, in the longitudinal direction. For suppose if I take this as a longitudinal axis, it will the strain will be there in the longitudinal direction. But at the same time, see if this is getting elongated in this direction, in the perpendicular direction, like in the lateral direction also, there will be change in the dimensions of the material. For suppose if this is an axial tensile load, here the change in the dimensions will be like it will get reduced. The diameter, for suppose if you take this as a circular number, the diameter will get reduced. Okay. If the length is getting increased, the diameter is getting reduced. That's why the ratio is actually represented by negative, represented with a negative sign, and the ratio is between lateral strain of the material to the longitudinal strain. And basically the limiting value of that is -1 to 0.5. This is the limiting value for it. And the next question is Comparing to mild steel plain bars, highly strength deformed bars are less ductile but more ductile but less strong, or more ductile and strong. I just explained the amount of, I just explained the scenario based on this amount of carbon content, right? See, if you take mild steel plain bars, if you take a comparison between mild steel plain bars and high yield strength deformed bars, in case of high yield strength deformed bars, yeah, you can ask someone raise the hand who would like to ask some question. You can ask me if you would like to ask any questions.
Hello. Please answer a previous question, ma'am.
So when you have a comparison between this high yield strength deformed bars and mild steel bars, here in case of high yield strength deformed bars, the amount of carbon content will be high, because of which the ductility will be less. The ductility will be less, and the ultimate strength will be more. The ultimate strength will be more in case of yeah. In case see, someone is asking the answer for the previous question. It is the limiting value of Poisson's ratio is between -1 and 0.5 Newton. And coming to this current question, we can say that this high yield strength deformed bar is less ductile but more strong. The high yield strength deformed bar is less ductile but more strong. So this depends on the amount of carbon content which is it has. Okay. And coming to the next question, Poisson's ratio is valid up to. What is the validity valid up to? Like valid up to means you should say in terms of whether it is valid up to this proportional limit, or it is valid in this plastic region, or it is valid in this Stein-Haganum region. Poisson's ratio is actually valid up to any anyone can answer this. It is actually valid up to the proportional limit, because the validity is up to when the strain is directly proportional to the stress. When the stress is directly proportional to the strain, then only this Poisson's ratio is valid. So the validity of the Poisson's ratio is up to only the proportional limit, because the Poisson's ratio, how we have arrived at the Poisson's ratio based on the Huxley states that within the proportional limit, the stress is directly proportional to the strain. So it is only valid up to the proportional limit, or it pertains only to the elastic ratio. Okay. Again, the question is Poisson's ratio is defined as the ratio of lateral strain to the longitudinal strain. And variability of strength of a material is taken into account in design terms. This is the question. And let me explain what is the variability of strength. What do you mean by variability of strength? Okay. First, let me explain you in which material this variability of strength is higher, and in which material the variability of strength is lower. First, basically, the variability of strength depends on two things. First, the uniformity of the material composition. For suppose the material is homogeneous. The material is homogeneous, like in any the material is homogeneous means at every point the properties of the material will remain constant. So it is made up of a single material. It is not made up of some mixed kind of material. So if the material is homogeneous, then you can see that the variability of strength is very less in them. When the material is heterogeneous, for suppose reinforced cement, concrete or concrete, stick cement or concrete, which is heterogeneous in nature. It is not homogeneous in nature because it is a mixture of many components like fine aggregate, coarse aggregate, water, cement. If you take concrete, it is a composition of concrete, cement, fine aggregate, coarse aggregate, and water. So it is not a homogeneous material. It is a heterogeneous material. So the variability of strength will be higher in case of concrete. In case of concrete, when compared to steel. Okay, so that is in concrete it is higher and in steel it is lower. And how we have to and what is this variability of strength? For suppose if I have molded some cubes of concrete and I have done this tensile load test in some universal testing machine, I will be able to draw this from the universal testing machine. I will be able to draw the stress strain characteristics of the cube. Okay, so if I test some n number of samples, uh, we cannot say that every sample from every sample we'll get the same we'll get the same strength. We'll get the same ultimate strength. Okay, we cannot say that uh, every cube will have the same strength as it is made of as it is a heterogeneous material. So what if we test some n number of samples and if you get the strength results differently, and so suppose if we draw all the strength results, then you will get a curve like this. You will get a curve like this. This is the normal distribution curve. This is the normal distribution curve. Okay. So, for suppose if you get a curve like this, and for suppose if you say on y-axis you have the number of tests you have done, versus on x-axis you have this strength. You have this strength. For suppose and if you have this normal distribution of it doing n number of tests, uh, see this pink is there. Right? You will be able to see this pink. We can say that this is the mean value. This is the mean value. What does this mean value represent? That means from this mean value, you can say 50% of the test results are lesser than this mean value, and 50% of the test results are higher than this mean value. So, can we rely on this mean value? See, what is the problem if we rely on this mean value? What will be the problem arising if we rely on this mean value? So if you rely on this mean value, what will happen is there are 50% chances that the material may fail. There are 50% chances that the material may fail. Okay. So if it is less than the mean strength, this 50% curve is there. 50% of the 50% probability that the material may fail in that particular kind of test. So this is not then it is not reliable. Right? You can't rely on this mean strength. That's why we have to go for some characteristic value. We have to go for some characteristic value. Okay. So this variability of strength of a material is taken into account in the design process characteristic value. Based on this characteristic value, uh, the variability of the strength of the material can be taken into account in the design process. Okay, and let me explain you what is the characteristic value. Okay, what is the characteristic value? So this is the mean value. Okay, and the design and material selection is safe value that corresponds to a value at which the probability of failure is at an acceptable level is called a characteristic value. So suppose if I say there is 50% chances that the material will fail, then we need to go for the material. No, right? We can't go for the material if we have 50% chances. That's why what we are going to do is when we have 5% failure chances, when we have 5% failure chances, when the material falls under this category, like when it has only the chances of 5% failure, then we can take the characteristic strength. If we take this mean strength, then you have 50-50 chances. But if you go with this characteristic strength, then you have 95% chances of not having any failure. But we have only 5% of chances of failure. Only 5%. See, if this is the mean strength, then we have 50% failure chances and 50% uh, chance of no failure happens. But if you go for this value, here the characteristic value, then from the characteristic value you can understand that only 5% of the test results may fall in this failure category. The remaining 95% of the test results are in no failure category. So that's why if you take this characteristic strength value, then you can say that on there are only 5% chances of failure to the material which you have taken. So the formula for this characteristic strength is mean sigma is mean targeted strength. So on x-axis you can see the strength values and on y-axis you can see the number of test results you have. Okay. So out of n number of test results, you have come up with this Lyman distribution of the curve. And so here this is the mean strength and this is the characteristic strength. So you can obtain the characteristic strength from the mean strength as mean strength minus this case is known as the standard deviation. Standard deviation. For suppose if you take the failure rate as 5%, if you want to take the characteristic strength of the materials here, then you can say this K value is equal to 1.64 and S is the standard deviation. Standard deviation. So you can say the characteristic strength is equal to the mean targeted strength minus 1.64 times the standard deviation. 1.64 times the standard deviation. To understand this, I'll show you a question. If you if you are able to solve the question, then you will be able to understand the concept of the characteristic value. Let me explain the question for you. Okay, the characteristic strength of concrete required in a project is 25 megapascal, and standard deviation in the observed compressive strength expected at the site is 4 megapascal, and the average compressive strength of the concrete is. Now, what do you have to find? Here the formula is characteristic strength is equal to mean strength minus 1.64 times the standard deviation. But here you have to find the mean value, like the average compressive strength. What you have to find? The average compressive strength of concrete has to be 4. Okay, average compressive strength has to be 4. But what you have to do? See here, compressive strength. So see here. characteristic is equal to 25 megapascal. Okay. So you have about sigma average and you know the standard deviation. Standard deviation is equal to 4 megapascal, right? So now the you know the sigma characteristic is equal to sigma average minus 1.64 times the standard deviation. So now to find out the sigma average, what you have to do, sigma average is equal to the characteristic compressive strength is 25 plus 1.49 standard deviation. So if you calculate this, what would be the value of the average compressive strength? 25 plus 1.64 into 4. Right? So 31.56 megapascal will be the average compressive strength of the concrete. Okay.
$31.56.
Hello.
Answer is 31.56.
Yeah, answer is 31.56. That is the answer. So now you understand how to arrive at the characteristic compressive strength and the average compressive strength. Vice versa. Like if you have been provided with the characteristic strength, how to find the average strength, and if you have this average strength, how to find the characteristic strength, and what is the characteristic strength? Okay. See, here the question is the mean strength of group of 4 non-overlapping consecutive cubes for M25 grade concrete should not be less than. This is the question. Okay, this is the question. What do you understand by this question? See, this concept also relates to this characteristic strength value concept only, because see, if you take four four cubes of concrete, okay, and for M25 grade, we have done the design for this M25 grade concrete, and you have casted different cubes out of the concrete, okay, and if you test the four consecutive cubes, then the M25 grade concrete, the grade of the concrete should not be less than 25, right? Should not be less than 25. The mean strength of group of four non-overlapping consecutive cubes for M25 grade concrete should not be less than 25 megapascal. Should not be less than M25 mega 25 megapascal. Okay. So these are the set of questions which I thought would be useful for solving your assignment problems, because as such assignment problems I can't discuss it here. So I have taken some sample questions which are related to the Week1 assignment, so that if you have any doubts pertaining to the assignment, you can get clear of those things. So this lecture pertains to the contents of Week1 and the assignment which is related to the Week1 content. Okay, and in the next week, in the coming up classes, we can see the contents of the Week2 and also the assignment questions for the like similar kind of questions related to assignment 2 can also be discussed in the next session. Now, if you have any doubts related to this particular session, you can feel free to ask me. Or else you can message in the chat box also. Whichever is feasible for you, you can do that. Any doubts?
Final exam.
Yeah.
In problem questions are give or only theory questions.
Okay. You are in final year, right?
Yes, ma'am.
Okay. See, this is the basic course in construction material. So, what is your doubt actually? Like the questions are of 30th standards? That's what you're asking.
Ma'am, can you repeat?
What is your doubt? If the questions are of 30th standard, that's what you're asking, right?
Yes, ma'am. Yes, ma'am.
Basic course. This is the course which will be taught in this.
Ma'am, your voice is
Um,
not audible. Breakdown.
is it
Yes, ma'am.
audible?
Yes. My question is in the main exam, only theory questions are give to me or given the question or some problem questions are also there in the paper.
Yeah, problematic questions also will be there because now this is only the beginning content, right? Later on, problematic questions also will be there. When you come up with this concrete mix design, there you have to do some concrete mix design problems. Just like that. If you study this bricks and all, then you will have to do some calculations for this tensile strength of concrete, steel. So there will be some problematic questions also. And at, in this subject, you can expect more of theory than problems.
But in college, my teacher has said that this is a complete theory paper.
But you can have some small problems will be there. That's what I'm saying. The course actually pertains to more of theory questions. Is some small problems will be there.
Okay.
But see, in the doubts clearing session or in this problem solving sessions, most probably I will concentrate on the questions which have this calculation parts and all, where you have to calculate some values and all. So I will concentrate mostly on that. So in that you can cover all the aspects which are related to that. Any other queries? Or if you have
I mean,
any,
in
uh, you know,
मैम असाइनमेंट में जैसा क्वेश्चन है वो डिटो फाइनल एग्जाम में वैसा क्वेश्चन आएगा कि मैम चेंज भी होता है थोड़ा.
it will not be similar. Assignment questions will be simple, but the final end semester exam will be a bit a bit more, not like assignment problems. Assignment problems are for practice. So when you complete the
means
week
you,
one content,
means you
it's like
say
a practice session for you.
means you said that assignment question and final paper question is not similar.
Yeah, it can't be similar.
Ma'am?
Any other one? Yeah, it won't be similar. Like it will be similar, but it won't be the same. Any
I
other
I
queries
I I can
related to the contents?
I can take one exam on NPTEL. The course name is Safety in Construction before 2 months. So in that paper, I found that the question in final exam and the question in NPTEL different.
Your voice is not audible.
Ma'am, my question is understand.
Yeah, but actually it varies from course to course. Though it is an NPTEL course, it will vary from one course to other. Okay. Um, anything else? Like any other queries related to the contents which have been taught in the, or any queries in the questions which I have explained, or any queries in the concepts, whatever it is. So if you don't have any other queries, uh, then I'll close the session for today.
And what is the benefit of this course certificate in future? If I go into job sector or if I can go for higher studies, then what is the benefit of this certificate? You can tell me in short.
Yeah, I mean, like if you have done a full course and if you get a certificate, it would be beneficial. For suppose if you go some construction industry or something, then it will be useful in your resume that you have done a course which is related to that domain. Then it would be useful.
And in also interview, it is useful.
Yeah, it will be useful. If you are into that particular domain, it will be useful for sure. Okay.
And one last question, ma'am. Last question.
Yeah. Yeah.
Can civil engineers can go for IT sectors and do coding like C, Java, Python?
It depends on personal interest actually. If you want to be in IT sector, then you can learn and you can go for that actually. It doesn't depend on the branch.
Suppose I go for IT sector, then what are the things I can do? Means how I join IT sector? Some extra course I can do or some extra co-curricular activities? Give
Yeah,
some
that
tips.
I'm not aware actually because I doesn't belong to any IT sector. If you want to go into some IT sector, probably you have to do more courses on that. Probably in NPTEL also you can find some courses related to that. Okay.
Give some tips to how to
Yeah, let us
get and
got
crack the IT sector job and interview also.
yeah. Now let us continue the this particular session for this course alone. Okay. So if you have any doubts in this particular course, you can ask me, like in this particular session, the contents of week 1 or the assignment problems or something, you can ask me, or else I'll wind up the session for today. Okay. Any queries from anyone? Okay, then. Winding up the session. So we'll meet next week in another session. Okay. Okay then. Thank you.
Thank you.